Today you will understand Wolff-Kishner reduction in a way you will never forget. In this reaction, ketone is converted into alkane in the presence of hydrazine, sodium hydroxide, water and high temperature. This reaction is about reduction. There is a addition of hydrogens or there is a removal of oxygen. You can see that ketone is converted into alkane, removal of this oxygen and addition of this hydrogen. This is reduction reaction. Role of each reagent and high temperature will discuss in the reaction mechanism. In the first step of mechanism, this hydrazine, which is a nucleophile having a lone pair, is going to attack on the electrophilic carbon. So now there is a bond formation between nitrogen and carbon, and this carbon will have 5 valency, and to stabilize that this oxygen will accommodate this lone pair, will accommodate this pi bond in the form of lone pair, and will have this intermediate. Nitrogen is positive and oxygen is negative. This oxygen needs one proton and this nitrogen wants to kick off one proton to be stable, and for that now base, which base, the sodium hydroxide base is going to come, and that OH minus from sodium hydroxide will grab proton from nitrogen and will form H2O. Now no more proton with nitrogen, so nitrogen is being stable. At the same time oxygen needs one proton, so now that oxygen further is going to abstract a proton from that formed water, that means H2O. So one proton this oxygen will abstract and will form OH. This is how this proton from this site is going to transfer to this with the help of base. This step is base catalytic proton transfer step, in which we are going to stabilize this oxygen and this nitrogen to drive this reaction forward. Now in next step, this hydroxyl is going to abstract one more proton from a water and will form H2O at this position. And now H2O, you all know that it's a good living group, so it is going to live. So now this H2O is going to live. You know, in the general reaction we have discussed that we have hydrazine, we have sodium hydroxide as well as water in this reaction, so that water is going to help for protonation, and thus this OH is going to protonated and will form H2O, and this H2O is going to leave. And when this H2 is going to leave, this bond between oxygen and carbon is going to break. This bond is going to break, and when this bond is going to break, who will get those electrons from bond? Oxygen, because oxygen is more electronegative than carbon, and so this carbon will have a positive charge. It will be electron deficient, and to stabilize that, this nitrogen, the adjacent nitrogen have a lone pair, and this will simply form a double bond between them, and now this carbon is being stable. But at the same time this nitrogen will have a positive charge because of the 4 valency. So now for stabilization of nitrogen, base is coming again and will abstract a proton from this nitrogen and again will form H2O, and now this nitrogen is being stable, and this compound this intermediate called a hydrazone. What it is? It is a hydrazone. So the hydrazone is going to form, which is a stable kind of intermediate in between. In this reaction, base is coming again and again for a deprotonation. At the same time, water is going to help for a protonation, and this is how this reaction is going forward. This is the same structure I just flipped in sideway, and now see this. Again, the base is going to come and abstract a proton. So base is coming again and will have a one proton from nitrogen and will leave as a water. The bond between nitrogen and hydrogen is going to break, and those electrons from the bond are accommodated on the nitrogen, and now this nitrogen will use that lone pair that electrons to form a double bond between this nitrogen and this nitrogen. So simply when this hydrogen left, this bond shift between nitrogen and nitrogen, and now the adjacent nitrogen is being positive with 4 valency. And now to stabilize this nitrogen, this carbon is going to accommodate this pi bond in the form of lone pair, and there is a formation of carbon anion, and this nitrogen is being stable. Though carbon is less electronegative, it is going to accommodate electrons and will stabilize this nitrogen. Now there is a formation of carbon anion. Again, water is there, and that water is going to give a proton, and now the water, this carbon anion, and it will abstract that proton and will form CH. No carbon anion. So simply we have added one proton, and we are nearer to our final structure, which is alkane. Now what thing we need to kick off to form an alkane? Simply we don't want this whole structure. And what thing is that, what atoms are there? N2. So that means what? We can kick off these nitrogens in the form of nitrogen gas, and then we'll add one more proton and we'll end up with alkane. And for that, to drive this reaction forward, to favor this step, we are going to introduce that high amount of temperature. Why? Because this is going to break that activation barrier. Yes, that activation barrier. If we want to kick off that nitrogen, we need to have that much amount of energy, and for that we are going to have this high temperature in this reaction. And now again, base is going to come and abstract that proton. So once the proton is going to left, this nitrogen gas can release. When this H left, this bond is going to form a triple bond, and now N2 gas is going to form. And to kick off this gas, this temperature will help, and now N2 gas is going to leave. After that, the bond between nitrogen and carbon is going to break, and this carbon will have this bond in the form of lone pair, and there is a formation of carbon anion again. Though carbon is less electronegative than nitrogen, carbon is going to have those electrons to drive this reaction forward. Because nitrogen gas is so stable, it don't want that electrons. So those electrons are coming to the carbon for a while only, and then this carbon anion will have proton again from water and will end up with CH2, and this is what our alkane is. You can see that CH2, R1 and R2. This is how we can simply reduce ketone into alkane, removal of that oxygen and addition of protons. Also you can use aldehyde instead of ketone. Now tell me in next lecture which reaction mechanism I should teach.